Hello, everyone, and welcome. Let's think about something for a second. How does a company like Amazon manage to get millions of different products to millions of different doorsteps pretty much on time every single day? I mean, it really does seem like magic, doesn't it? But it's not. It is pure mathematics. And more specifically, it's the power of matrix algebra. Today, we are going to pull back that curtain and meet the secret agents that make it all happen, special matrices. And trust me, these are not just some abstract ideas from a textbook. They are the very tools that drive modern logistics, finance, and business strategy. All right, let's get into it. So here's our roadmap for this session. We're going to start by meeting our special agents and really get a handle on why they're so important. Then we're going to do a deep dive on three of the most crucial players: the identity matrix, the diagonal matrix, and the zero matrix. And finally, we'll bring it all together and see how understanding this theory lets you model and solve some incredibly complex business problems. By the end of this, you'll start to see the real architecture behind all that magic. Okay, so what exactly makes these matrices special? Well, imagine for a moment you're a marketing analyst at Netflix. You've got this gigantic matrix, right? The rows are all your users, millions of them, and the columns are all the movies and shows they've rated. It's just a chaotic sea of data. A special matrix is one that has a predictable, really rigid structure that can bring order to that chaos. It has a very specific mission. For instance, you could use one type to instantly figure out an average preference score for a user, a task that would otherwise take a ton of computational power. Think of them as your shortcuts, your benchmarks, your starting points. They are the fundamental building blocks for making sense of a world that is absolutely built on data. We're going to begin with what I honestly consider to be the Rosetta Stone of matrix algebra, the identity matrix. Seriously, if you only take one thing away from our discussion today, I want it to be a deep, solid understanding of this matrix. Why? Because it is the absolute key that unlocks our ability to solve for unknowns in systems of linear equations. And you're going to find that almost every major business optimization problem, from supply chains to financial portfolios, can be boiled down to exactly that. Now, let's focus on this term here, neutral element. It sounds a bit abstract, so let's make it concrete. In the math you've known your whole life, the number 1 is the multiplicative neutral element, right? Anything you multiply by 1 just stays itself. Well, the identity matrix, which we write as a capital I, does that exact same job, just in the world of matrices. You can think of it like the control group in a scientific experiment. It's that stable, unchanging baseline that we can use to measure the effect of all our other matrix operations. It is our standard, it is our benchmark. So this right here on the screen, this is where it all comes together. This is where the theory becomes incredibly powerful. So let's break this down, piece by piece. The formula says that some matrix, we'll call it A, multiplied by its inverse, that's the A with the little -1 exponent, is equal to the identity matrix, I. So what on earth is an inverse? Well, in the world of numbers, the inverse of 5 is 1/5, because 5 times 1/5 gets you back to our neutral element 1. The matrix inverse, A-inverse, is the one unique matrix that, when you multiply it by A, gets us back to our neutral element, the identity matrix. Now, a very common point of confusion for students is to ask, well, why don't we just divide by matrix A? And the answer to that is fundamental. Matrix division is simply not a defined operation. You cannot do it. Instead, we use this much more elegant approach. We multiply by the inverse. This is the core mechanism that lets us isolate and solve for an unknown matrix, just like dividing by 5 lets you solve for x in the equation 5x equals 10. This is probably the single most important solving technique you're going to learn. Okay, so why are we spending so much time on this? Let's put you in the hot seat. You've just been hired as the new logistics director for a company that ships, let's say, 10,000 different products from 5 warehouses to 100 retail stores all across the country. You've got shipping costs, warehouse capacities, store demands, fuel prices. All of them are changing daily. It's a dizzying web of variables. But here's the thing. You can represent this entire complex system as one massive matrix equation, AX equals B, where A holds all your costs and constraints. To find the optimal, cheapest shipping plan, that's the matrix X you're solving for. You can't divide by your cost matrix. You must multiply by its inverse. By applying that principle from the last slide, you unlock the solution. You find the single plan that saves your company millions of dollars. That is the power of the identity matrix. All right, let's move on to our next special agent. If the identity matrix is the key that unlocks the solution, then the diagonal matrix is the supercharger that gets you to that solution with incredible speed. And in the modern business world, think high-frequency trading, big data analytics, real-time forecasting. Speed isn't just a nice-to-have. It's often the difference between profit and loss. And the diagonal matrix is your secret weapon for that computational efficiency. Now, the definition here is deceptively simple. A diagonal matrix is just a square matrix where the only numbers that aren't zero are sitting on the main diagonal, that perfect little staircase of values that runs from the top left corner down to the bottom right. Everything else, all that other space above and below, is just zero. And you might think that makes it weak, but that clean, sparse structure isn't a weakness. It is its greatest strength. It's where all the important information is concentrated with absolutely no noise surrounding. Now, this bullet point here looks pretty modest, but I promise you its implications are profound. Let's say you're a financial analyst and you're trying to project the growth of a client's 500 stock portfolio over the next 10 years. This would involve raising a matrix of growth factors to the 120th power, one for each month. Now, for a regular dense matrix, that calculation is a computational nightmare. Your computer could literally be churning on that for hours. But if you can represent that system with a diagonal matrix, well then, you just have to raise each individual number on the diagonal to the 120th power. What took hours now literally takes seconds. And this isn't just about being faster. It allows you to run thousands of different simulations, stress testing that portfolio against different market conditions, which means you can provide your client with vastly superior advice. This is how modern quantitative finance actually works. So we've gone from the key that unlocks problems to the lightning speed of complex computation. Now we're going to turn to the profound power of absolute simplicity. Our third and final special agent for today is the zero matrix. And please, don't be fooled by how humble it looks. At first glance, yeah, it's just a grid of zeros. But in the world of business modeling, the concept of nothing is often the most important place to start. It is our clean slate. This concept should feel pretty intuitive. Just like the identity matrix was the matrix version of the number 1, the zero matrix, which we denote with a capital O, is the direct equivalent of the number 0. It's what we call our additive identity. I like to think of it as a blank canvas before an artist makes the first stroke of paint. It represents the absence of value. Zero inventory, zero sales, zero budget. It's the definitive baseline from which all growth and all activity is measured. And this property right here perfectly illustrates its function. If you add the zero matrix to any other matrix A, it leaves A completely unchanged. Now, this is absolutely crucial for establishing the initial conditions in business models. For example, many of the most financially disciplined companies in the world use a process called zero-based budgeting. At the start of a fiscal year, a department manager doesn't just get to ask for, say, a 3% increase on last year's budget. No. Instead, their starting budget is modeled as a zero matrix. They have to build a case and justify every single dollar, from salaries to software subscriptions, from the ground up. This process, which is rooted in this very concept of a zero baseline, forces accountability and is one of the most powerful tools out there for cutting waste and optimizing spending. Okay, let's just pause and really focus on this slide for a moment, because this is probably the single most common area of confusion for students when they first learn this material. You absolutely have to be able to distinguish between these two roles. The zero matrix is for addition. It is your starting point, your clean slate, your nothing. The identity matrix is for multiplication. It is your benchmark, your control group, your one. A frequent mistake I see on exams is students trying to use the identity matrix to set an initial state, or using the zero matrix in a multiplication problem. They are distinct tools for very distinct jobs. So let's create a little mnemonic right now. Think zero is for originating a value through addition, and identity is for isolating a variable through multiplication. So let's bring it all together. We've just met 3 really powerful special agents. We have the identity matrix, that's our brilliant solver, the key that unlocks complex systems. We have the diagonal matrix, our high-speed accelerator, the expert in computational efficiency. And we have the zero matrix, our foundational baseline, the origin point for all our models. Now that you've been introduced, you have the fundamental vocabulary to start building sophisticated models that can describe, predict, and optimize real-world business outcomes. You know, this isn't just an abstract academic exercise. I once worked with a mid-sized manufacturing firm that was just plagued by production bottlenecks. Their whole assembly line was modeled as a system of equations, but the solution was just elusive. We were stuck for weeks. The breakthrough finally came when we correctly used the identity matrix to isolate the single variable that represented the bottleneck machine. That aha moment, which came directly from these fundamentals, allowed them to completely restructure their workflow, and it ended up saving the company millions. This is where theory really hits the balance sheet. So, to leave you with a challenge, I want you to think back to that Amazon or Nike scale supply chain problem. Now that you know the basics of these matrices, how would you, as a consultant, use them together to build a more efficient and sustainable system from the ground up? How might a zero matrix define the start of a brand new distribution center? How could a diagonal matrix model the variable shipping costs to different regions of the country? And how would the identity matrix be that ultimate key to solving the entire puzzle and finding the one single optimal path? I'll leave you to think on that. That is the power of these fundamentals.